Standard form. Let's see together what is it and how can we use it. So, if we consider standard form, it's just another way to write the same number in a different way, and possibly in certain circumstances in an easiest way. So if we take 300, instead of writing it as 300, we can write it as 3 times 10 to the power of 2. So you see it's the same number because 10 to the power of 2 is 100. 100 times 3 is 300. So why do we use it? Because in certain case, number can be extremely big and complicated, and so we can write, for example, 4.5 times 10 to the power of 25. You can imagine that this one is very long to write in a normal way. So we use standard form. What are the rules to write standard form? Well, we said there is a number, then multiply times 10 to the power of something. So a number times 10 to the power of something. We know that this number, the multiply times 10, should be bigger than 1 and smaller than 10. While the exponent could be everything. It could be a positive exponent, a negative exponent, and there is no limitation to its size. So, for example, 12 times 10 to the power of 3 is not in standard form because 12 is not smaller than 10. So we should have to write 1.2 times 10 not to the power of 3 because we just reduced this by 10, so we have to increase this one by 10. So we write to the power of 4. Alright? Standard form can be used also to simplify operation. For example, if you have two standard forms that multiply together, like this one, 4 times 10 to the power of 3 times 8 times 10 to the power of 9, we can use this property. Let's say that a to the power of n times a to the power of m. We don't actually have to do all the calculus. It's just a to the power of n plus m. So in this case, what we have to do, our a is clearly 10 here and there, and we have to sum the two exponents, 3 and 9. So we will know that we will have 10 to the power of 3 plus 9, so basically 10 to the power of 12 multiply times this, there is 4, and this, there is 8. So we can multiply 4 and 8 together, that is clearly 24, and we can write 24 times 10 to the power of 12. Now, this is the solution, yes, absolutely, but remember that we have to write into standard form. So we will convert this 24, that this 24 is actually bigger than 10, so we cannot accept it, in 2.4. But if we reduce this by 10, we have to increase this by 10, so we compensate. So this would be 10 to the power of 13. So this is how we do multiplication in standard form. Let's see how do we do division. We got a to the power times 10 to the power of 9 divided by 4 times 10 to the power of 3. Now we use a property that is quite close to the one before. They say a to the power of n divided by a to the power of m. We don't have to do everything, we just do a to the power of n minus m. So once again we just use the exponent n and m and we subtract it, and so we got the solution. Once again, in this case, a would be 10, then we got 10 on top and on bottom, and we will just do the difference of the exponent. So we got as times, we got a divided by 4, we can do this part before, and it's clearly 2, and then we got what we said before, 10 to the power of 9 divided by 10 to the power of 3, we just do 9 minus 3, and we got 10 to the power of 6. Now be careful that when I divide a number like 10 to the power of 3 divided by 10 to the power of minus 2 would be 3 minus minus 2. So it's not 1 because minus and minus, this minus and this minus, compensate each other. So we be like to write 3 plus 2, so it's 5. So don't make this mistake because you can easily lose mark on this. Now let's see how to do sum and subtraction is actually the same thing with standard form. Now, don't get confused with the power that we said before, the property. We cannot actually do a to the power of n plus a to the power of m is equal to something that we know. We cannot do this. This is actually wrong. So don't make the mistake to consider this, the sum, as an exponent or as a product or as a division. We cannot actually use some property. The best thing to do, there are several ways using to get quicker, but in order to not get confused, we can just transform the first number in a full number, a normal number, so would be 30,000, and the second number in a normal number as well. Sorry, I keep moving everything. The second number is a normal number as well, so we can just 500,000. So to be clear, this one is this number and this one is this number. Should be 400, sorry, should be 400. Now we have to sum these two together, so we just do the sum. 0 plus 0 is 0, 0, 0, 0, 3 plus 0 is 3, 0 plus 4 is 4. So we got 430,000. Now if the exercise tells you that you have to give the solution, the result, into standard form, once again we have to convert this one into a number between 1 and 10. That will be 4.3 times 10 to the power of something. What power of what? Well, we just count how many times we are going to move the comma. The comma at the beginning is there, at the end it will be there, so we just count one position, 2, 3, 4, 5, so it's actually 10 to the power of 5. Now remember that when we move in the comma on the other way, for example 0.01, we have to consider a negative exponent, so it will be number 1 between 1 and 10 would be 1, but we move the comma from here to here, so we just, from here to there, so we just move 1 and twice, so it will be 1 times 10 to the power of minus 2, because we move in this direction. So when we move left to right, the exponent is negative. When we move right to left, the exponent is positive. Hopefully you learned something and this video helped you somehow, and good luck.